Hello, pre-algebra. Not gonna lie, today is a long lesson. So buckle in. Hope you've got your warm, tasty beverage like I do. And let's take this bit by bit, piece by piece. I think you guys will be able to get the concept, but I've got lots of examples. So hope this helps. And let's just get started. We are talking about lengths and areas of similar regions. What we're doing is we are comparing ratios with proportions. So if you really like the proportions, the cross multiplying, if you think that's super duper easy, this is going to be great. You're going to catch this no problem. So let's say we've got these two triangles. Triangle ABC is similar to triangle XYZ. Because they're similar, we know they have the same angles, but one is larger than the other. So let's say we have ABC, XYZ, right? Okay, so they're set up in the correct form. And we have ABC with these values here and XYZ. We probably shouldn't call this X, but that's the way it is. Why don't I call it H? I'll just change it to H. We have these values here, and we need to solve for H. So there's a few ways that we could go about this, right? We have that the line XZ is equal to the line AC. Rather, it's corresponding. It's not going to have the same value. And the ratio of XZ over ZY is going to be the same proportion, the same ratio as AC over CB. Therefore, we can set up this proportion cross multiply and solve for this value. Right? So we know that, again, remember I changed this to H. So we could cross multiply. So H times 4 is going to be 4H. 8 times 5 is 40. Now I've got 4H equals 40, so I'm going to divide by 4 and solve to find that H equals 10. Oh yeah. Easy money. So again, this is just review. It's fairly simple and straightforward. A little bit of multiplication, a little bit of division, easy money. Okay. When we do this for perimeter, the corresponding sides of two similar triangles. So here's an example. Are 16 inches and 12 inches. So again, so whether it's this side and this side, right, this is just an example. The perimeter of the first triangle is 55 inches. Find the perimeter of the second triangle. Now you might wonder, well, we don't know all the sides. How could we find the perimeter? We can do this same process to solve for the answer, right? We can use a proportion. Okay, so we have 16 and 12. The first triangle is 55 over, we could call this X. So what I've done here is I've done side over side. Why don't I call this side 1 over side 2 equals perimeter 1 over perimeter 2. This is your primary ratio. When we're talking about sides and perimeters, this is what we're working with. Okay. And now we cross multiply. Okay. So that's going to give me 16x equals 12 times 55 is 660. Now I'm going to divide by 16. And with the help of a handy-dandy calculator and work that was already done for me, I solve that x equals 41.25, and we know the units are inches. You might be thinking, wow, that's really easy. And you know what? Sure is. Straightforward. It's important that we keep it organized as far as what we're doing. And the thing to keep in mind is this phrase right here. When we're talking about perimeter, so perimeter, if I had a highlighter, I'd highlight that, but perimeter, the ratio of the sides equals the ratio of the perimeter. That's what I had here. I'll write it again. So let's say side 1 over side 2 will always equal perimeter 1 over perimeter 2. Okay, now again, this is for perimeter. But at the top of the notes, we were talking about area as well. Area gets a little bit more complicated, but it's not that much. It's one extra step. So when we're talking about area, the ratio of the area is equal to the ratio of the sides squared. So perimeter has normal units, area has squared units. Here's what it looks like. Area 1 will equal area 2, right? That's the ratio of the area. But it's going to be side 1 over side 2, but this ratio is squared. That's what it looks like here. So the only difference is that I'm squaring my sides here, right? Perimeter has normal units, normal. Area has squared units, so you square it, right? If these are squared, these need to be squared as well, right? Because it's going to be inches squared or centimeters squared, whatever it is. So if these are squared, this needs to be squared. Okay. Don't worry, I've got plenty of examples. So the first one. The first two similar pentagons, right? It doesn't matter if it's triangles, pentagons, rectangles, doesn't matter. But as long as they're similar, which these guys are, and it has a side of 4 centimeters, the second has a side of 3 centimeters, what is the ratio of their areas? Okay. So again, we have, let's see, I think I have it written out. Okay, so the ratio of the sides is 4 over 3. But we know up there, it's got to be squared. 4 squared over 3 squared, right? You apply the exponent to both terms. So it equals 16 over 9. Equals area, and that should be centimeters squared. Okay, here's another example. So let's say we have A, B, C, D, E, F, and we know that these two triangles are similar. So triangle ABC is similar to triangle DEF. Okay. What's the ratio of the sides? Okay, let's just start there. Ratio of the sides is going to be 4 over 12. 4 over 12. Now, can we simplify that? Sure can. That fraction simplifies to 1/3. Okay. So the perimeter is going to have perimeter ratio. So whatever this perimeter is, now we don't know what these sides are, so we don't know exactly what the perimeter is, but this perimeter will be 1/3 this perimeter. And that's just because of the ratio. So if this perimeter ends up being 10, this perimeter will be 30, so on and so forth. But what about the area ratio? Well, we take the ratio of the sides, which is 3, or rather 1/3, and we square it. So because it's squared, I need to apply that exponent to the top and bottom. 1 squared is 1, 3 squared is 9. Right? Now, here's a couple notes. The ratio of perimeter equals ratio of the sides. So no matter what this ratio is, it's going to be the same as that one, right? The ratio of the sides is the same as the ratio of the perimeter. And here, ratio of area equals ratio of the sides squared. Okay. I know I'm repeating myself, but this stuff proves difficult for a lot of people, which is fine, no problem. It's just why I'm going over it and over it and over it. Okay, I've got one more page for us all. So now what if I only have the areas on one side? Well, this is a little bit more tricky. So here's an example. Let's say I have these are two pentagons, right? They've got 5 sides. The area of this first one is 100 millimeters squared. The area of the second one is 400 millimeters squared. My side 1 is 9 millimeters. My side 2 is x. Now again, what we can do is we could set up a proportion. Right, we have 100 over 400 and 9 over x, but this one needs to be squared. Now before we can multiply, we've got to do our exponents, right? Exponents come before multiplication. Now what I'm going to do before I multiply, because multiplying 81 times 400 just seems daunting, I'm going to simplify this fraction. And by simplifying this fraction, I'll have 1 over 4 equals 81 over x squared. Totally legal. Can do, 100%, no problem. Well, now what? Now I cross multiply. Oh yeah, don't forget you have to square for the area. Okay, so now I'm going to have, after cross multiplying, I have 1 times x squared is x squared. 4 times 81. Now I'm going to do a little trick. I'm going to keep them separated, and here's why. How do I get rid of the exponent? By squaring it. Now, I know the square root of 81. I also know the square root of 4. If I multiply those guys, I don't know if it has a square root. Right? 81 times, let's see, what would that be? 81 times 4. Yeah, 81 times 4 is 324. The square root of 324 equals question mark? I don't know. So this is just a little math trick where you can hold off, knowing the future steps, you can hold off on all of the multiplication. Now, you'd be able to find it out. You would just have to do the factor tree. It's kind of ugly, so I'm going to take the square root of both sides. It's the square root of x squared. Well, that's just x. The square root of 81 is 9. The square root of 4 is 2, equals the square root of 81 times the square root of 4, which is 9 times 2, which is 18. And that should be millimeters squared. Oh, no. It's not squared because it's the side. So this last side is 18 millimeters. Okay. I can imagine you saying, wait a second. So let me walk through that again. I've got my area 1, area 2. So this is area 1, area 2. Remember, I'll just show it over here. A1 over A2 equals, this will be side 1, and this is side 2. But with sides and areas, we need to square this bad boy. So that's how we get here. Now I do need to do my exponents before I can multiply or divide. So then I've got 100 over 400 equals 81 over x squared. I'm going to simplify this because I don't want to multiply by 400. After cross multiplying, I get down here. X squared equals, I could have said 324, absolutely. But I kept them as separate factors to make this step easier. After taking the square root of 81 is 9. The square root of 4 is 2. I'm still multiplying them, which gives me my final answer, x equals 18 millimeters. I think I have one more example. Now this one doesn't have pictures, but it has all of the components. Okay, so let's say I have, now this time I have two sides, but I don't have my second area. So very similar process, except I'm solving for my second area. So I'm going to set these into a proportion, and again I'm going to square the sides. Now you might say, wait a second. The area is supposed to go on the left and the sides go on the right. Well, you could switch them back and forth, no problem. That doesn't change anything in math. As long as you take the whole piece and put it over on that side, it's fine. It's the same thing. Okay, so now I need a square top and bottom. That's going to give me, let's see, 36 over 49 equals 30 over x. Well, now I can't simplify either of these. Right, I can't simplify this fraction, so I am just going to have to multiply. So 49 times 30 equals 1,470. And I'm going to set that equal to 36x. Aren't you guys glad you have calculators? Then we divide both sides by 36, leaving us with the area as roughly units squared. Okay, Hope this helps. If you guys have questions, please let me know. I know this is a lot of work, but it's important for you guys to know, so that way you can let me know. Otherwise, I love you. Ask, and I will be seeing you guys in our Zoom chat tomorrow. Bye.